All right, everybody, this is the video for Module 5, Lessons 8 and 9, where we're going to be talking about area. And the difference between area from 4th grade to 5th grade is that we're going to be using a little bit of fraction work here. So let's do a little review. I want you to skip a couple lines under today's title, and I want you to write the equation to find the area of a rectangle or a square, and then we'll explain what that means. So area equals length times width. Simple as that. Now, we used area this year. We used an area model, for example, to multiply fractions. Those were the ones that we drew the fraction up and down one way with diagonal lines. Then the other fraction we're multiplying going across with other diagonal lines. When they overlapped, that was the answer. That's technically what we're doing today, but looking at it from a different lens. The other way you might see this written on, like, let's say a reference sheet is a capital letter A, which represents area, and they just write LW, meaning length times width. So let's say we skip a line, draw a medium-sized rectangle, and we want to find the area of it. So what they're asking for is how many squares, because that's how we measure area, fill up this space in the middle, okay? So this isn't something you can just use a measuring tape or a ruler and measure from here to here. We need something else to measure a flat space like this. So we use squares, because squares are a nice flat shape with the same side length and width. So for example, if this was a square that was 8 foot long and 3 foot wide, there's two ways we can solve this. Number one is we could draw the squares, right? So since there's 8 going this way, you could draw 7 lines up and down. 2, 3, 4, 5, 6, 7. Remember, 7 lines makes 8 spaces if you count those up. And 3 feet would mean we draw 2 lines going this way across, and then we make a bunch of squares, and all you'd have to do is count them up. But if you use the equation and they give you the length and the width, you could just multiply them together, and you would know, using mental math, that 8 times 3 is 24. And now, because these aren't straight feet, right? This isn't just 24 rulers in a row. These are squares. We have a symbol for this, and it's something you already know. It's the exponent of 2. We also have heard earlier this year that the nickname for this is squared. And now you see why, because when we're talking about a square foot, this would be 1 square foot, 1 foot wide, 1 foot long. So we have 24 of those, and we represent it with the exponent of 2. Okay? So that's a little bit of 4th grade review. Now let's take a look at what they're going to be doing on your classwork and your homework. And we are combining 2 lessons today because they are very closely related. But I'm going to take one right off of your homework for the lesson 8 side. And what they're going to do is they're going to give you a square. And they're going to say that this square is just 1 square. So instead of having like 8 feet by 3 feet, we're just going to say this is, let's say, 1 unit, or like 1 foot. But a unit can be anything. It could be a foot, it could be an inch. But this is 1. So if I want to know a smaller version than 1, then we're going into fraction lands, because fractions are everything less than 1. So on the one on your homework, they have 3 lines going up and down, and 3 lines going side to side. So let's do that now. That wasn't that great. Let me fix that up. I want them nice and even so they actually look like squares in there, not rectangles. So remember, we measure area with squares. So if I were to ask you, like the homework does, like how many square tiles are used to partition, which means to split up the unit squares into what they are, you would say that there are 16 tiles, we'll call them, or squares. So write that to the side. And then they might ask something like, well, what's the length of each square tile? So if I want to know, let's say we draw a little thing here with a question mark, a little bracket. If I want to know what's the width of any one of these squares, since they're all the same size, there's an easy way to do that. Just count how many there are across. There's 1, 2, 3, 4. And the same thing going down the width. Because this is 1 unit, this is not 1 whole, this is 1/4 of a unit for the question mark. So I'm going to put equals the question mark just so we know what we're talking about there. So that would be the first 2 answers for your homework questions, but I wanted to explain what was going on there, okay? Now, there's going to be a lot of work that we do in class today to supplement this, so I don't want to give too much of the homework away so that you actually have to pay attention in class today, but I just wanted to show you that one right there. Okay, for the next one, you're going to skip a couple lines and draw another unit square, but this time the book might present one with outlines in it to represent the squares, but this is also 1 unit, so let's write that to the side. Meaning anything inside is going to be a fraction less than 1, okay? And I noticed on the homework, they say, okay, if this thing was filled with squares, let's say this big, so draw a little square next to it, and each one of those, let's say, was 1/9 of a unit, now you can kind of guess how many would be in there accurately. So I want you to think about this. If each one of these little squares were put in here, there'd have to be 9 spaces going across, meaning you'd have to draw 8 lines up and down and 8 lines side to side. But without doing that and saving some time, you could figure it out. Think about this. If there are 9 columns and 9 rows, I'm just going to symbolize that with this and this, and they ask you how many square tiles with the length of this are needed, there would be a total of 81 tiles. Okay, so that would be the answer to a question like that. So again, if I were to draw 8 lines up and down, 8 side to side, it's the same thing as using the area model for multiplication. You would have an array of 9 times 9. But these are not 9 wholes, these are 1/9. But if I'm just counting the tiles, there'd be 81 of them. But now let's say, what is the area of just one of these, okay? So this is a 1/9 unit. So what you would do is, I'm going to draw an arrow down, and I want you to do that too. I want you to think of this thing as 1/9 long and 1/9 wide. And if I want to know what's the area of this, you just do length times width of the small thing. So don't forget, with fractions, you just multiply straight across. So right underneath, write 1/9 times 1/9. Draw your arrows across. And the actual size of one of these little tiles is not 1/9, that's just the side of it, is 1/81st. Okay? And we're going to say, because this doesn't have an exponent we can write or a measurement, we're just going to write square units. And I'm just going to write unit because that's less than 1. So that's how you find the area of a smaller square within a bigger one. Okay, a little confusing, but we'll get some practice in class for that. So then we're going to be flipping to some pages in our workbook and the side of our homework that says lesson 9 on it. And lesson 9's pretty much the same thing with area, except we're going to be organizing, counting, and representing a collection of square tiles. So now I'm going to erase this and we're going to do another one. So I'm going to take one right from your homework right now. So I want you to skip a couple lines, and this one is right on your homework on the side that says lesson 9. It gives you a rectangle that's 3 foot wide and 4 foot long, okay? Now, this in 4th grade, they would just say, what's the area of this in square feet? And you would just do area equals length times width, so write that down. And just like drawing the 3 lines up and down for your 4 and your 2 lines going across for your 3, you'd get an array, and that array would be 3 times 4, which is 12 square feet. Okay? But unfortunately, that's not what they're asking on the homework. But it is helpful to find that first. So what did I just do visually? Remember, if I have 4 going up and down based on the bottom, each one of these being a foot wide, and then 3 feet going across, so 3 lines up and down, boys and girls, and then 2 going across, because that makes 3 sections for the 3 feet. there are 12 square feet. But on the homework, they go into fraction land and say, how many square tiles with side lengths of 1/4 of a foot are needed? So they're saying how many smaller squares would be needed. These are too big right now. These are a full foot. I need them to be 1/4 of a foot. So without going crazy with the drawing here, we can figure this out mathematically by just looking at one of these squares, okay? So what I'm gonna do is just really quickly, and you might have drew this too small and that's okay. So you do not have to do this part, but for studying purposes, this is good to visualize. What they basically are saying is that if you want squares that are not 1 foot wide like this one, but 1/4 foot wide, that means you gotta put 3 little lines up and down this way and 3 little lines going across this way to split that up into fourths, both lengthwise and widthwise. Holy cow, that would be a lot of little squares. But if you can figure out one of the squares and multiply it by 12, since there's 12 of them, you'll be okay. So think about this. You just cut this into 4 spaces this way and 4 this way. 4 times 4 is 16 little squares in one of these. So if I do 16 times 12, I will be able to find my answer. And this is double digit multiplication, so I'm gonna need my X's and O's, but I'm looking at the digits and they're not too bad. So you cover up the 1, good review here. 6 times 2 is 12, carry the 1. 2 times 1 is 2, plus 1 is 3. Always multiply, then add. Then do your X's and O's. And then do the same thing with the 1 that your finger was over. 6 times 1, reach to the right, is 6. 1 times 1 is 1. I have my 2 partial products, I add them up. And now without having to do this on every square and try to figure out how many squares are in this whole thing, I now know if I were to split this rectangle up, this original rectangle up, not by 3 and 4, but by 1/4 of a foot, there would be 192 tiny little squares taking that up, okay? So the answer to that question on your homework is 192 squares. So why is the answer so big? Again, in 4th grade, they would probably just ask you for how many square feet. That would be the big boxes. But they want to know how many 4th sized, which you don't see that on my notes, but right here they say it. 4th size feet are needed to cover the rectangle. That means you got to split each one of these up into fourths this way and this way to make those little squares. Okay, so I did 3 lines up and down, 3 lines right to right. That's 4 times 4 is 16. So that is challenging for some because you got to do some higher order thinking, but that's 5th grade math for you, and that's the best way I can explain it. But the video could probably go on for 20 more minutes. We don't want to do that to you. So we're just going to practice in class and tackle this together. And then that way, hopefully, all of your questions get answered that way through exploratory learning and just through questioning too, because this is very doable. You just have to really have your math brain on for this. So good luck, follow along, and as always, ask questions if you're getting stuck. Good luck.